Hi, in this lecture, we will be continuing our discussion on predictive modeling, especially the regression analysis and modeling that we are continuing. If you went through the diabetes measurement scoring prediction notebook that we have shared earlier, and this was a regression task, and this lecture is mostly about another notebook that we have shared already through Blackboard, and it's on my GitHub. So this is about the medical insurance cost prediction, and here I'll be covering a few important topics that is kind of universal idea for any machine learning task, although we are here focusing on the regression task. But the same applies to any predictive modeling if you are doing the classification task, which we will be covering next week. Okay. So in summary, this covers some encoding of categorical features and also data normalization or feature normalization. So let's go to the notebook that I have already shared. So it's regression underscore insurance. And as I mentioned that I'll be covering feature encoding and feature normalization. This is along with some other things that we'll be doing as we move forward. I have posted the data on my GitHub, and here is the link. So let's load the data first along with all the modules that we used earlier. So we'll be doing a regression through few models: linear regression, then random forest regressor, and gradient boosting regressor, and support vector regressor. 4 models. Okay. And in terms of metrics, we'll be using mean squared error. So let's load the data. And you see the data looks like this. So you have age feature, then sex feature, body mass index, BMI, then how many children the person has, whether he or she is a smoker or not, and I think where the person is actually resides. And this is the charges, so this is what we have to predict, And if I compare with the other notebook that we discussed in the last video, all the features were normalized and all the features were actually pre-processed, meaning that they were all numeric and the values were within 0 and 1. Okay. But here we see that the age is integer, then sex is categorical, and then this is again floating point, but the scale might be different. And then there are few categorical values, and the y variable or the predictor variable is numeric or floating point. Okay. So we have to do a little bit processing before we do the modeling. Again, for some models, you can use this data as it is, which I'll be explaining, but some other models require the data to be pre-processed. So here I'm just separating the data frames into the feature data frame and then levels. And here I'm just plotting on a specific variable. So x-axis is BMI, body mass index, and then y-axis the costs. And you can see that although here you have a horizontal pattern here, but for most of the cases we see a linear trend, so the body mass index and the cost are correlated. Okay. Now we see some summary of the feature data frame. So we can see that the data types are actually integer, then object, then floating point. So here I am actually separating the categorical or object data types and the numeric data types. So we see that the age, BMI, and children, these are numeric categories, and sex, smoker, and region, these are categorical features. So in one of our lecture we discussed about one-hot encoding, and here I'm just doing the same for one particular feature. So the first feature is the age. So here I am using pandas method, what we call get dummies, pd.getDummies, and then if you pass the feature column, and you can specify that what will be the prefixes of your new columns and this will convert your categorical data into one-hot encoding. Let's look at what happens. So here we see that we have created a new data frame that is actually converting this column, the sex column, converted into one-hot encoding. So again, you have two options, female and male. So for each record, you will have one values to be 1, the other to be 0. So this is the idea of one-hot encoding. If we recall, we have 3 categorical features. So we do the same for all the features. Then we store all the on-hot data frames as a list. And then here we're concatenating the features data frame with all the numeric feature columns and then one-hot data frames here. So now we have a data frame df underscore all underscore numeric, and you see the age and BMI column whereas it is, and children column as well, and then the rest columns we have created by using the on-hot encoding process that we have just explained earlier. So now we have a complete data frame with all the numeric features. The remaining thing is now we have to scale our data. So scaling means we'll be converting all the values, all the column values to be within 0 and 1. So here we are using the scikit-learn min-max scaler. You are actually instantiating the min-max scaler, and then you are just doing fit transform using your df all numeric. And if I run, now you see that all the values now are scaled between 0 and 1. So you see that the values are within 0 and 1. You can check with other values. Age, again the value is 0 and 1. So all the values became in the range between 0 and 1. And here we're just converting the data into NumPy arrays because this is what we'll be passing it as our feature and label columns. So all good. So here we are instantiating our linear regression model using the code that we used in our last presentation. So here we are instantiating our linear regression model by passing the scikit-learn linear regression, and we are doing class validation using all the data and all the levels. So that's the summary. So if I run that, you get some numbers. The numbers are around 37 million, but let's not focus on these numbers because here the cost is actually kind of in the range of few $1,000, and that's why you have a big numbers here, but that's not the focus today because in future we will be focusing on how to improve these numbers. Okay, so using linear regression we got these number, and let's not focus on the negative value here because here we are converting from error to scores. So you have a negative mean in square. So this was our score for the linear regression model, and now we do the same for the random forest model. And we can see the numbers are kind of quite low compared to the linear regression. This is also expected, because the random forest models are actually quite strong in terms of modeling these kind of problems. We do the same for support vector regression, and this one is the results for the gradient boosting regression. So in summary, the main concept that we learned, given that any data format, how we can process the data and use those data to do our modeling. Two important concepts that came into our study today. One is that how do we convert from categorical data to numeric data using one specific technique, what we call one-hot encoding. And the other one is how we can scale the data using min-max scaler. Please take your time to run this notebook, and if you have any question, feel free to ask me. Thank you so much.